We now discuss the solution of a problem that has appeared in TS Set 2023 March examination. The question is related to the number of nilpotent elements from the section rings, broadly from the section algebra. And this discussion about this problem is suitable for the aspirants of JL, DL, AP Set, TS Set, IIT JAM, GATE and CSIR NET examinations also. Yes, this question has appeared in TS Set 2023 March and the question number is 73 with this question ID. The given question is let R is equal to Z by 6Z, that is the quotient ring, Z by 6Z be a ring. Then the number of non-zero nilpotent elements in the quotient ring Rx, the polynomial ring over R, by the ideal generated by x square is, we are given 4 options. So we have a ring Z by R given by Z by 6Z and required to find the number of non-zero nilpotent elements of this quotient ring R bracket x, Rx, that is the polynomial ring, by the ideal generated by x square. Let's now discuss the solution of this problem in detail. We have R Z by 6Z, which is isomorphic to Z6. Yes, it is isomorphic to Z6. And we are given the polynomial ring R bracket x. This is the set of all polynomials with the coefficients coming from this ring R, that is Z6 bracket x. Agreed? Let I, normally the ideal is denoted by I, is equal to the ideal generated by x square be the ideal of Z6x generated by x square. And who are the elements of I? All those polynomials which appear as x square into gx, where gx belongs to Z6x. So all multiples of x square, where the multiples will be x square multiplied by g of x, where g of x is a polynomial from Z6x. That is the ideal generated by x square. We have the quotient ring. Yes, we have the ideal, we have the ring R. So the polynomial ring by the ideal generated by x square is Z6x by I. And who are the elements? The elements are the cosets, that is I plus ax plus b, where ab belongs to Z6. And why we have written ax plus b? Why not ax square plus bx plus c? If you write ax square, that will be merged with I and will become I only. So therefore I plus ax plus b, where ab belongs to Z6. So how many elements are there in the quotient ring? A takes values 6 values, b takes 6 values. So the total number of these cosets in this quotient ring will be 6 into 6, 36 will be there. Out of these 36 elements in this quotient ring, how many of them are nilpotent? Right. So note that the zero element of Z6x by I is I only. I. Yes. In this quotient ring, who is the zero element? I. Right. Now, who are the elements of I? I is the ideal generated by x square, is the set of all those polynomials which appear as x square times gx, where gx is a polynomial coming from Z6x. Agreed. Agreed. Now, what is that we want to find? Required to find the number of non-zero nilpotent elements of this quotient ring Rx by the ideal generated by x square, that is same as Z6x by I. So what is, by the by, what is a nilpotent element? You are familiar with the concept of the nilpotent, but however, here is a snippet you can see. Let R be a ring with unity. An element A belongs to R is said to be a nilpotent element if there exists a positive integer n such that a power n is equal to 0 element. Right. And the 0 element belongs to R. 0 power n is 0. So 0 is always a nilpotent element. But what we want is, in this example, is non-zero nilpotent elements. Agreed. So we deal with the discussion with two cases. In the case 1, we take I plus AX plus B, in that B is an element of Z6, B is equal to 0. Then the elements of Z6x by I will be I plus AX. Take I plus AX, square it, that is I plus AX multiplied by I plus AX. And when you multiply, how do you multiply the quotients? I plus AX into I plus BX, suppose if you are given, then it will be I plus AX multiplied by BX, that is I plus ABX square. That is the quotient multiplication. So here I plus AX into I plus AX will be I plus AX whole square, that is A square X square. Agreed. Now A square X square belongs to I. Why? Because the elements of I are the multiples of X square. So A square X square is a multiple of X square. So this also belongs to I. So I plus I is I. So I plus AX whole square is equal to I, where I is the 0 element of Z6x by I. So that's I plus AX is a nilpotent element. So I plus AX is nilpotent for all A belongs to Z6. If you take A is equal to 0, it will be I. I is the 0 element of that quotient ring. There, what we want is non-zero nilpotent elements. Therefore, the non-zero nilpotent elements in that quotient ring are I plus x, A not equal to 0 you have to take. So I plus x, I plus 2x, I plus 3x, I plus 4x and I plus 5x. These are the 5 non-zero elements. So in the answers, the 5 is appearing against option 1. Now the question is, are there any other non-zero nilpotent elements? That's the question. So that means most probably you have to, there might be some non-zero elements when B not equal to 0 in the case 2. So let's go and investigate in the next slide. Right. So that's what we have done so far. Let's go for the case 2. Let B not equal to 0. So in this, first you note down. You take any non-zero element of Z6. Now, is it a nilpotent? So take for example 1. 1 square is 1. And any number of times 1 to the power of n will not give you 0. Therefore 1 is not nilpotent. You take 2. 2 non-zero. 2 square 4 non-zero. 2 cube 8 modulo 6 is 2. So 2 will be any number of times you raise to power n will give you either 2 or 4 and will not give you 0. Like that you verify 3, 4, 5. So no non-zero element of Z6 is nilpotent. So that is your first observation. You require that one in the next discussion. So let I plus AX plus B nilpotent, B not equal to 0, B is equal to 0 we have already discussed. Now, because it is nilpotent, this is your assumption, is an assumption you are making. So there exists a natural number n such that I plus AX plus B to the power of n is I. Now multiply I plus AX plus B multiplied by I plus AX plus B multiplied by I plus AX plus B, like that n times. That will be I plus AX plus B to the whole to the power of n is equal to I. So I plus ax plus b to the power of n is equal to I will imply ax plus b to the power of n belongs to I. Right. Ax plus b to the power of n belongs to I. Now let us expand this by means of binomial, and one may ask a question, is the binomial theorem valid here? Yes. A, B are in Z6 and U are and R6, Z6 bracket X is a commutative ring. So in all cases commutative ring is there. So even in the quotient ring also. So when commutative ring is there, you can have your binomial. So ax plus b to the power of n expanded by means of binomial, b power n plus nc1 into b power n minus 1 into ax plus sigma r is equal to 2 to n ncr into b power n minus r into ax to the power of r, that belongs to I. Right. So in this you take a x square common. These are all the terms whose degree is greater than 2. So now the first two terms as it is, plus you take x square common, then this will be sigma r is equal to 2 to n ncr into b to the power of n minus r into a power r into x to the power of r minus 2. You have a commutativity, therefore all these things will follow, belongs to I. Now what is this? This is x square multiplied a polynomial. This is a polynomial in Z6x. So this belongs to I as per this. So this will be b power n plus nc1 b to the power of n minus 1 into ax belongs to I, because this belongs to I, this goes this side and I. So I is the bracket x square. So who are the elements of I, that is bracket x square? So if every term is of the form x square into gx, and let us look at the degree of x square gx. It will be at least 2. But whereas b power n plus nc1 b to the power of n minus 1 into ax is a polynomial of degree 1, that belongs to I, which is not true. This is not true, since the least degree of the polynomials that are there in I, that is the ideal generated by x square, is 2. It's a minimum degree is 2. But this is a degree of 1. So therefore this is not true. This is not true because of your false assumption that I plus ax plus b is nilpotent. Therefore this contradiction tells you that I plus ax plus b is not nilpotent when b not equal to 0. So we have considered b is equal to 0, b not equal to 0, all the cases are over. So no element I plus ax plus b, b not equal to 0 is not nilpotent. So who are the nilpotent elements? So these are the non-zero nilpotent elements, are just the one what you have already found: I plus x, I plus 2x, I plus 3x, I plus 4x, I plus 5x. How many? 5. So therefore the number of non-zero nilpotent elements in Z6x by I is 5. So these are the 5 non-zero nilpotent elements. So let's look at our options. Our answer 5 appears against option 1. Therefore the answer to this question is option 1. So that is the detailed discussion of the solution of the problem on the nilpotent elements in a given context. I am sure that you understood the solution of this problem. I have been doing or making videos for the benefit of the aspirants of IIT JEE mains exam and CSIR net exam, now this TS set, AP set, IIT JAM and GATE examinations. If you like my videos, please like, share and subscribe. and my channel's name goes by my name, Professor K. Satyanarayana. Please subscribe and share. I wish you all the best. Thank you.